Hello, today we are going to solve a complex familiar question. It's a methods question. Show that there is only one point of inflection on the curve for this function, hx. Use mathematical reasoning to justify your response. Okay, let's do the point of inflection. We know point of inflections, we need to decide to investigate what is second derivative. So equal to 0. So to find out what x is. All right, so that's our goal. So let's do first derivative first. So will be 20 x to the power 3 plus 10 x squared and minus 100 plus 5. So that's the first derivative. Then the second derivative will be 20x to the power 3 plus 60x squared plus 40. 20x minus 100. So this is our second derivative. So we want to just simplify. We got 20, take common factor out. 3x squared plus x minus 50 minus 5. So we want to equal to 0 to solve for x. So let's do that. So now this is a cubic function. So in order to solve for x, we need to try. So we say let x to be 1. So then we say h substitute into equation 20. 1 3 times by 1 squared plus 1 minus 5. Yeah, which is just equal to 0. So therefore, so the h double dash x must be equal. So x minus 1 must be one of the factor. So we say the other expression we can call qx. So therefore we need to decide what's qx. So qx will be h double dash x divided by x minus 1. So that means we substitute 20. So it's 3x squared plus x minus 5 divided by x minus 1. All right, so how do we do the division? So we're going to use a long division. So long division, we put x cubed plus 3x squared plus x minus 5 and divided by x minus 1. So this is a long division. Let's do the first, which would be x to the power of 2. So it will be first x cubed minus x squared. So the subtraction, so before x squared plus x. So then we times plus by 4x. So let's do a subtraction again. So that will be 5x minus 5. So the last number will be plus 5. So that's 0. So therefore our qx will be, this is our qx. So therefore our second derivative, we have 20 multiplied by x minus 1 and times by qx, which is x plus 4x plus 5. So if we let equal to 0, so we already achieve one suspect turning point of inflection is x to 1. Do we have another one? So we want to prove only one. So that means we need to prove the x plus 4x plus 5 cannot be equal to 0. All right, so let's do that. So how we do it, we use a determinant. So determinant is a b squared minus 4ac. So b is 4, so 4 squared minus 4 times by 1 times by 5. So that'll be 16 minus 20, so it will be negative 4. So which is less than 0. So therefore, this x squared plus 4x always greater than 0. So it cannot be equal to 0. So therefore, the x equal to 1, and then we substitute is the only solution for point of inflection. All right, so if you want to just try to find out what is the y, so if we substitute back to original function, so hx, so let's use 1 to replace x. So I'm going to wipe it out. So we substitute 1 into the equation. So let's give us, so if we substitute to equation, actually what I'll do is I'll go to here because I can see the equation. So h1 equal to 1 to the power 5, 5 times 1/4 plus 10, 3, 50, 1 squared plus 5 plus 2. So the answer will be 1 plus 5 plus 10 over 3 minus 50 plus 5 plus 2. So the end up is 10. So we 40, negative 40, take, so be 10 divided by 3 minus, so these two cancel it out with 40. So we negative 37. So the answer will be 3, 10. So it's a negative number, is that? So it's a negative 1, 1, 1. So the answer will be negative 1 and 1. So this is the f, so therefore the only point of inflection is 1, negative 101 divided by 3. So that's it. So this is the only solution we can have. So that's, so therefore is the turning point, is the, sorry, point of inflection. All right, question solved. Thank you for watching, and see you next time. Bye.